November 1943, Bougainville Island. Two Marine squads face the same Japanese defensive position across a jungle clearing. Both have 12 men. Both have M1 Garands. Both have the same orders. Take that ridge. The first squad attacks with rifle fire alone. 8-round clips, aimed shots, tactical discipline. They advance 50 yards before withering enemy fire pins them down. Casualties mount. They withdraw. The second squad attacks differently. 3 men carry Browning automatic rifles. As they advance, these bar gunners unleash continuous automatic fire, 600 rounds per minute from each weapon. The volume is staggering. The Japanese defenders can't lift their heads. The squad reaches the ridge in minutes with minimal casualties. Same mission, same enemy, different outcome. The difference: 3 automatic rifles that military experts had dismissed as too complex for combat use. John M. Browning's impossible bar design had just proven that firepower, not marksmanship, would decide the Pacific War. But the story of how one stubborn engineer's innovation transformed infantry tactics begins 25 years earlier, in a factory where everyone said automatic rifles would never work. Before we dive into how the bar changed warfare forever, I want to ask you something important. This channel explores the untold tactical innovations that won World War II, the weapons and decisions that textbooks ignore. If you appreciate these deep dive stories, hit that subscribe button and join our community of military history enthusiasts. And tell me in the comments, where are you watching from? Did you know that the bar remained in service for over 50 years across multiple wars? Now, let me tell you how one automatic rifle gave American infantry unstoppable firepower. September 1917. John Moses Browning stood in the testing facility of Winchester Repeating Arms Company, New Haven, Connecticut. At 62, the legendary firearms designer had already revolutionized modern weaponry with his automatic pistol, the M1911, and machine gun designs that armed armies worldwide. But the project before him represented his most ambitious challenge yet: creating an automatic rifle that could be carried and operated by a single infantryman. The military specifications seemed impossible. Weight under 20 pounds, so soldiers could carry it along with ammunition and equipment. Automatic fire capability of at least 300 rounds per minute to provide suppressive firepower. Reliability in mud, sand, rain, and extreme temperatures. Simple enough that conscript soldiers could maintain it under battlefield conditions. And most critically, it had to work with the standard .30-06 Springfield cartridge already in Army inventory. Every firearms expert Browning consulted told him the same thing: you cannot build an automatic weapon that powerful in a package that portable. The recoil forces would be uncontrollable. The mechanism would be too complex. The weight would be prohibitive. Fixed that, they insisted, soldiers needed belt-fed machine guns operated by crews, not individual automatic rifles that tried to do too much. But Browning possessed the quiet confidence of an engineer who had been proven right before. His M1911 pistol had been dismissed as too powerful for military service until field tests showed it could stop charging enemies that lighter calibers merely wounded. His water-cooled machine gun had been rejected as too complex until demonstrations proved its reliability exceeded simpler designs. The breakthrough came through elegant mechanical simplicity. Instead of complex recoil systems or gas traps that required precise machining, Browning designed a gas-operated action that tapped expanding gases from the barrel to drive a piston. The piston pushed the bolt backward, extracting the spent cartridge and compressing a return spring. When the spring released, it drove the bolt forward, stripping a new round from the 20-round magazine and chambering it for firing. The entire cycle took 1/10 of a second. Pull the trigger and hold it, and the rifle fired continuously at 550 rounds per minute. Release the trigger, and the mechanism stopped instantly with precise control. It was revolutionary in its functional simplicity, only 74 moving parts compared to over 200 in comparable machine gun designs. But making it work required solving problems no designer had faced before. The .30-06 cartridge generated massive recoil energy, over 20 foot-pounds per shot. Multiply that by 550 rounds per minute, and the forces became nearly uncontrollable. Browning's solution was a combination of mechanical buffers, precisely calculated spring tensions, and a weighted bolt assembly that absorbed recoil energy progressively rather than transferring it directly to the shooter's shoulder. The first prototype weighed 24 pounds, 4 pounds over the military's maximum specification. Every component was scrutinized for weight reduction without sacrificing strength or reliability. The barrel was fluted to remove metal while maintaining rigidity. The stock was crafted from walnut instead of heavier hardwoods. The gas cylinder was precision machined to minimum wall thickness. Each modification shaved ounces that accumulated into pounds. By February 1918, Browning had a functioning prototype that weighed 19.5 pounds loaded with a 20-round magazine. On a cold morning with snow falling outside the Winchester facility, he conducted the demonstration that would change infantry warfare forever. Military observers from the Army Ordnance Department watched as Browning fired 600 rounds through the prototype without a single malfunction. He then field-stripped the weapon, immersed it in muddy water, reassembled it, and fired another 200 rounds flawlessly. The observers were stunned. Nothing in their experience prepared them for an automatic rifle that could sustain such fire rates with such reliability. One officer, Colonel Isaac Lewis, voiced the concern that echoed through military establishments. This weapon will consume ammunition faster than supply chains can deliver it. Equipping infantry with automatic rifles means logistics nightmares. Browning's response to the ammunition concern was characteristically methodical. He had calculated exactly what his automatic rifle would mean for infantry tactics. A standard infantry squad of 12 men armed with bolt-action rifles could deliver approximately 60 aimed shots per minute collectively. The same squad with 2 Browning automatic rifles could deliver over 1,100 rounds per minute when necessary, plus the rifleman's aimed fire. The tactical implication was staggering. Firepower that previously required a dedicated machine gun crew with a heavy tripod-mounted weapon could now be distributed throughout the squad. Every fire team could suppress enemy positions while teammates maneuvered. The entire concept of infantry assault was about to change. The Army adopted the weapon in July 1918 as the Browning Automatic Rifle Model 1918, immediately shortened to BAR by soldiers who would carry it through 2 world wars in Korea. But World War I ended before significant numbers reached the front lines. Only 85,000 BARs were manufactured before the armistice, and most remained in stateside training facilities. The interwar years nearly killed the BAR. Army Chief of Staff General Charles P. Summerall argued in 1928 that automatic rifles represented wasteful expenditure of ammunition without corresponding tactical advantage. Budget constraints forced infantry regiments to choose between maintaining BAR inventory or purchasing newer bolt-action rifles. Many units chose rifles, reasoning that marksmanship mattered more than volume of fire. But a handful of forward-thinking officers recognized the BAR's revolutionary potential. Lieutenant Colonel George S. Patton, commanding the 3rd Cavalry, conducted extensive tactical experiments at Fort Myer, Virginia, from 1928 to 1931. His conclusions, published in a classified infantry journal article titled "The Tactical Employment of Automatic Rifles," would prove prophetic. The BAR transformed squad tactics from successive rushes under covering rifle fire to continuous assault under automatic suppression. A properly trained BAR gunner can neutralize enemy positions that would otherwise require artillery preparation or prohibitive casualties to overcome. Marine Corps Captain Lewis B. Puller, who would become the most decorated Marine in history, made the BAR central to his tactical doctrine during the Banana Wars in Nicaragua. His small unit actions against larger guerrilla forces demonstrated that sustained automatic fire created psychological shock effects far beyond the actual casualties inflicted. Enemy formations broke and fled when faced with continuous fire they couldn't match. By 1935, Army and Marine doctrine officially incorporated the BAR as the foundation of infantry squad firepower. Standard organization called for 1 BAR per 8-man rifle squad, with the BAR gunner and assistant gunner forming the base of fire while riflemen maneuvered. The Japanese studied these American tactics carefully, noting in their intelligence assessments that U.S. infantry relied heavily on automatic weapons rather than traditional marksmanship and close combat. Japanese tactical doctrine emphasized different principles. Infantry squads of 9 to 13 men typically included 1 light machine gun, but it required a 3-man crew and was designed for stationary defensive positions rather than assault operations. Japanese commanders believed that rifle marksmanship, bayonet charges, and night infiltration would overcome American reliance on firepower. They would learn otherwise at terrible cost. Production ramped up slowly as war approached. By December 1941, when Pearl Harbor brought America into World War II, approximately 160,000 bars equipped Army and Marine units. But demand exploded overnight. Every infantry regiment needed hundreds. Paratroop units wanted lighter versions. Tank crews requested them for close defense. Even Navy vessels wanted bars for repelling boarders and defending against small boat attacks. Winchester, Colt, and the Springfield Armory retooled production lines for maximum output. Monthly production reached 10,000 weapons by mid-1942. But quality control became the obsession that kept ordnance officers awake at night. Each bar required precision machining with tolerances measured in thousandths of an inch. A gas port drilled slightly off-center could cause malfunctions. A bolt face machined incorrectly could result in catastrophic failure. Browning's response to the ammunition concern was characteristically methodical. He had calculated exactly what his automatic rifle would mean for infantry tactics. A standard infantry squad of 12 men armed with bolt-action rifles could deliver approximately 60 aimed shots per minute collectively. The same squad with 2 Browning automatic rifles could deliver over 1,100 rounds per minute when necessary, plus the rifleman's aimed fire. The tactical implication was staggering. Firepower that previously required a dedicated machine gun crew with a heavy tripod-mounted weapon could now be distributed throughout the squad. Every fire team could suppress enemy positions while teammates maneuvered. The entire concept of infantry assault was about to change. The Army adopted the weapon in July 1918 as the Browning Automatic Rifle Model 1918, immediately shortened to bar by soldiers who would carry it through 2 world wars in Korea. But World War I ended before significant numbers reached the front lines. Only 85,000 bars were manufactured before the armistice, and most remained in stateside training facilities. The interwar years nearly killed the bar. Army Chief of Staff General Charles P. Summerall argued in 1928 that automatic rifles represented wasteful expenditure of ammunition without corresponding tactical advantage. Budget constraints forced infantry regiments to choose between maintaining bar inventory or purchasing newer bolt-action rifles. Many units chose rifles, reasoning that marksmanship mattered more than volume of fire. But a handful of forward-thinking officers recognized the bar's revolutionary potential. Lieutenant Colonel George S. Patton, commanding the 3rd Cavalry, conducted extensive tactical experiments at Fort Myer, Virginia, from 1928 to 1931. His conclusions, published in a classified infantry journal article titled "The Tactical Employment of Automatic Rifles," would prove prophetic. The bar transforms squad tactics from successive rushes under covering rifle fire to continuous assault under automatic suppression. A properly trained bar gunner can neutralize enemy positions that would otherwise require artillery preparation or prohibitive casualties to overcome. Marine Corps Captain Lewis B. Puller, who would become the most decorated Marine in history, made the bar central to his tactical doctrine during the Banana Wars in Nicaragua. His small unit actions against larger guerrilla forces demonstrated that sustained automatic fire created psychological shock effects far beyond the actual casualties inflicted. Enemy formations broke and fled when faced with continuous fire they couldn't match. By 1935, Army and Marine doctrine officially incorporated the bar as the foundation of infantry squad firepower. Standard organization called for 1 bar per 8-man rifle squad, with the bar gunner and assistant gunner forming the base of fire while riflemen maneuvered. The Japanese studied these American tactics carefully, noting in their intelligence assessments that U.S. infantry relied heavily on automatic weapons rather than traditional marksmanship and close combat. Japanese tactical doctrine emphasized different principles. Infantry squads of 9 to 13 men typically included 1 light machine gun, but it required a 3-man crew and was designed for stationary defensive positions rather than assault operations. Japanese commanders believed that rifle marksmanship, bayonet charges, and night infiltration would overcome American reliance on firepower. They would learn otherwise at terrible cost. Production ramped up slowly as war approached. By December 1941, when Pearl Harbor brought America into World War II, approximately 160,000 bars equipped Army and Marine units. But demand exploded overnight. Every infantry regiment needed hundreds. Paratroop units wanted lighter versions. Tank crews requested them for close defense. Even Navy vessels wanted bars for repelling boarders and defending against small boat attacks. Winchester, Colt, and the Springfield Armory retooled production lines for maximum output. Monthly production reached 10,000 weapons by mid-1942. But quality control became the obsession that kept ordnance officers awake at night. Each bar required precision machining with tolerances measured in thousandths of an inch. A gas port drilled slightly off-center could cause malfunctions. A bolt face machined incorrectly could result in catastrophic failure. The first major test of the bar in Pacific combat came on August 7, 1942, when the 1st Marine Division landed on Guadalcanal. Private First Class John Basilone carried his bar ashore in the first wave, wading through chest-deep water while holding the 19-pound weapon above his head. Within hours, he would discover what Browning's design could do against determined infantry assault. The Japanese attacked Marine positions at the Lunga River on October 24 with overwhelming numbers. 3 battalions, approximately 3,000 soldiers, launched a coordinated night assault against a Marine perimeter defended by 400 men. The Japanese doctrine called for rapid infiltration followed by bayonet charges that would overwhelm defenders before American firepower could be brought to bear. They had not accounted for the bar. Basilone's section held a critical position covering an approach through dense jungle. As Japanese infantry emerged from the treeline, Basilone opened fire with sustained automatic bursts. 20-round magazines emptied in seconds. He grabbed fresh magazines that his assistant gunner, Private Steve Evanson, slapped into his hand without pause. The rhythm became mechanical. Fire, empty magazine drops, fresh magazine loads, fire again. The volume was devastating. Basilone fired over 500 rounds in the first 15 minutes of contact, a rate of fire that would have been impossible with bolt-action rifles or even the Japanese light machine guns that required careful tripod positioning and prone firing positions. The bar could be fired from standing, kneeling, or prone, could be shifted from target to target instantly, could deliver sustained fire without crew repositioning. Japanese assault formations broke against the automatic fire like waves against rocks. Soldiers who survived the initial contact reported to their commanders that they faced impossible firepower. Intelligence officers analyzing the engagement estimated that one Marine bar gunner had neutralized over 30 attackers, forcing an entire company to withdraw and seek alternative approaches. But the real tactical revolution was happening at squad level across the entire Guadalcanal campaign. Marine rifle squads had developed the coordinated fire and movement tactics that would become standard throughout the Pacific War. The bar gunner and his assistant established a base of fire, suppressing enemy positions with automatic bursts. While enemy soldiers kept their heads down under that fire, riflemen maneuvered to flanking positions. Once the riflemen reached their new positions, the bar shifted fire to cover them. This required training that went far beyond marksmanship. Bar gunners learned to fire short, controlled bursts rather than emptying magazines wildly. 3 to 5 round bursts maximized ammunition efficiency while maintaining sustained suppression. Assistant gunners became experts at ammunition management, knowing exactly how many magazines remained and when to call for resupply. Rifle squad leaders learned to read terrain and coordinate timing so that movement happened during peak suppressive fire. The Japanese had no effective counter to these tactics. Their doctrine emphasized individual marksmanship and coordinated assault, but both required soldiers to expose themselves to take aimed shots or charge forward. Against bar suppressive fire, exposure meant death. Japanese soldiers who lifted their heads to fire found themselves immediately targeted by automatic bursts. Those who attempted banzai charges ran into walls of lead that cut down entire formations. By December 1942, Japanese tactical reports from Guadalcanal painted a grim picture. American squads possess automatic weapons that provide sustained fire our forces cannot match. Attempts to close with enemy positions result in prohibitive casualties. Traditional infiltration and assault tactics are ineffective against volume of fire that does not diminish. The mathematics of firepower had shifted decisively. A Marine rifle squad with 2 bars could deliver over 2,000 rounds per minute when necessary. A Japanese infantry squad with bolt-action rifles could deliver perhaps 100 aimed shots per minute. Even accounting for Japanese light machine guns, the firepower ratio remained heavily in American favor. The strategic implications of bar firepower superiority extended far beyond individual engagements. Japanese commanders faced a tactical dilemma with no good solution. Their infantry doctrine, developed through years of combat in China, emphasized aggressive assault and close combat where Japanese soldiers' willingness to accept casualties would overcome material disadvantages. But the bar made close combat nearly impossible. Lieutenant General Harakichi Hyakutake, commanding Japanese forces on Guadalcanal, recognized the problem in his January 1943 operational report to Imperial headquarters. American automatic weapons create defensive zones our infantry cannot penetrate without artillery preparation that reveals our intentions and positions. By the time artillery ceases and assault begins, American forces have repositioned and our casualties mount exponentially. The Japanese attempted several tactical adaptations. They increased emphasis on night attacks when American fire discipline was harder to maintain and targets were difficult to identify. They adopted infiltration tactics that avoided direct assault in favor of bypassing strongpoints. They even experimented with smoke grenades and concentrated mortar barrages designed to suppress American positions long enough for infantry to close. None of these adaptations solved the fundamental problem. Night attacks succeeded initially, but American units quickly adapted by improving night defensive positions with interlocking fields of fire where bar gunners could sweep approaches even without clear visibility. Infiltration tactics worked occasionally but required terrain and conditions that weren't always available. Smoke and mortars helped but couldn't neutralize the volume of automatic fire waiting when the smoke cleared. By mid-1943, Japanese tactical doctrine had evolved into defensive warfare focused on fortified positions that American firepower would require time and casualties to reduce. The aggressive assault tactics that had characterized Japanese operations from China to the Philippines were abandoned as suicidal against American automatic weapons. The bar had forced an entire military to change its fundamental approach to combat. Meanwhile, American production of bars accelerated to meet demand across multiple theaters. Monthly output reached 15,000 weapons by 1943. But quantity meant nothing if quality suffered, and quality control became the obsession that dominated Ordnance Department priorities. Each bar underwent rigorous testing before acceptance. Function tests fired 100 rounds through each weapon to verify cycling reliability. Accuracy tests at 300 yards ensured that barrels were properly machined and sights correctly aligned. Stress tests subjected random samples to 10,000-round endurance trials under conditions that simulated extended combat use. Sergeant Arthur Wilson, a Marine Corps armorer on Guadalcanal, described the maintenance challenges that came with deploying thousands of automatic weapons in jungle conditions. The bar is reliable if you maintain it, but jungle rot is brutal on any steel. We stripped and cleaned every weapon daily, sometimes twice if we saw action. The gas cylinder required particular attention because carbon buildup could slow the cycling rate or cause malfunctions. We trained every bar gunner to field strip their weapon blindfolded because you might need to clear a malfunction at night under fire. The training pipeline expanded to meet demand for qualified bar gunners. Army and Marine recruit depots established specialized courses teaching automatic rifle operation, maintenance, and tactical employment. Students learned to fire from multiple positions, manage ammunition efficiently, and coordinate with assistant gunners who carried extra magazines and provided security. The best graduates were designated as primary bar gunners, a position that carried both prestige and risk since automatic weapons drew concentrated enemy fire. By late 1943, the ammunition disparity that defined Pacific combat became statistically overwhelming. A typical American infantry company conducting offensive operations carried approximately 50,000 rounds of .30-06 ammunition distributed among riflemen, bar gunners, and machine gun crews. A comparable Japanese company carried perhaps 8,000 rounds total for all small arms combined, with strict orders to conserve ammunition and fire only at confirmed targets. The logistics behind this disparity revealed America's industrial supremacy. Lake City Army Ammunition Plant in Missouri produced over 4 million rounds of .30-06 daily by 1944, working 3 shifts around the clock. Twin Cities Army Ammunition Plant, Frankfurt Arsenal, and Denver Ordnance Plant added millions more. The combined output of American ammunition factories exceeded 10 million rounds per day, enough to supply every rifle, bar, and machine gun in the Pacific Theater with surplus remaining for training and reserves. Japan's ammunition production, by contrast, struggled to reach 500,000 rounds daily across all calibers. Raw material shortages, Allied bombing of industrial facilities, and shipping losses meant that Japanese units in forward areas operated under constant ammunition rationing. Soldiers who had trained to fire 100 practice rounds during basic training now received fewer than 20. Units that had once conducted regular live-fire exercises ceased training entirely to preserve ammunition for actual combat. The tactical consequences were devastating for Japanese forces. Private Takashi Yamamoto, whose diary was captured on Bougainville, described the psychological impact of fighting with limited ammunition against an enemy with unlimited supply. We are ordered to fire only when certain of a hit. 10 rounds per day is our allocation. But the Americans fire constantly, not aiming carefully but saturating areas with automatic fire. We cannot return fire without exposing our positions and expending precious ammunition. We can only hide and wait for them to come close enough that marksmanship matters more than volume. American tactical doctrine exploited this disparity ruthlessly. When encountering resistance, standard procedure called for overwhelming suppressive fire from all available weapons. Bars, rifles, and machine guns would saturate suspected enemy positions with hundreds of rounds while assault elements maneuvered. The Japanese, unable to return fire without depleting their limited ammunition, had 3 options: remain pinned until overrun, attempt to withdraw under fire and risk casualties, or engage and quickly exhaust their ammunition. Captain James Roosevelt, commanding a Marine Raider battalion on Macon Atoll, described the tactical reality in a letter to his father. We advance behind a curtain of automatic fire that the Japanese simply cannot match. Our bar gunners fire 3 to 5 round bursts continuously, walking fire across any position that might harbor enemy soldiers. By the time we reach their positions, they are either dead, wounded, or so suppressed they cannot effectively resist. I have seen Japanese soldiers with loaded rifles who never fired a shot because they couldn't lift their heads under our suppressive fire. The Battle of Tarawa in November 1943 provided stark statistical evidence of firepower supremacy. Over 3 days of intense combat across an island measuring barely 2 miles long, American forces expended over 2.5 million rounds of small arms ammunition. The Japanese garrison, which had stockpiled ammunition for weeks anticipating the assault, fired an estimated 150,000 rounds total. The kill ratio reflected this disparity. Approximately 4,500 Japanese casualties against 1,000 American deaths, with many American losses occurring during the initial landing when naval gunfire failed to suppress Japanese positions rather than in sustained infantry combat where bar firepower dominated. By 1944, Japanese tactical manuals had been rewritten to reflect the reality of fighting American firepower. New doctrine emphasized deep underground fortifications, camouflaged positions that would reveal themselves only during close assault, and acceptance that most defenders would die in place rather than attempt maneuver under American automatic weapons fire. The psychological impact of sustained automatic fire extended beyond immediate tactical advantages. Japanese soldiers who survived encounters with American infantry consistently reported that the continuous sound of bars firing created stress and fear that exceeded the actual physical danger. Combat psychiatrists studying Japanese prisoners in 1944 found that the distinctive hammering rhythm of multiple bars firing simultaneously triggered panic responses even in veteran troops. This psychological dominance manifested in changed Japanese tactics. Rather than aggressive infantry assault, Japanese commanders increasingly relied on static defensive positions designed to exact maximum casualties while accepting that the position itself would eventually be overrun. The transition from offensive to defensive warfare represented a fundamental admission that Japanese infantry could not maneuver effectively against American firepower. Lieutenant Colonel Louis Chesty Puller, commanding the 1st Marine Regiment, recognized that the bar had become the psychological center of infantry combat. In training exercises at Camp Pendleton, he emphasized that bar gunners must maintain fire discipline even under stress because the sound of automatic fire supported friendly morale as much as it suppressed enemy action. His standing order to bar gunners was simple. If you hear enemy fire and cannot see the source, shoot where you think they are. Make noise. Let them know we have automatic weapons and ammunition to use them. By 1944, American tactical doctrine had evolved to maximize bar effectiveness through organizational changes. Standard rifle squads now included 2 bars instead of 1, creating overlapping fields of automatic fire. Fire team leaders learned to coordinate burst patterns so that one bar reloaded while another continued firing, maintaining continuous suppression. This required precise timing and communication that only experienced squads could achieve consistently, but units that mastered the technique became nearly unstoppable in offensive operations. The Battle of Peleliu in September 1944 demonstrated both the power and limitations of bar-centered tactics. American Marines equipped with multiple bars per squad advanced through murderous terrain against Japanese defenders using fortified cave positions. The automatic weapons provided crucial suppressive fire, but the caves neutralized much of the firepower advantage because Japanese soldiers could fire from protected positions and retreat into tunnels when suppression became overwhelming. Casualty statistics from Peleliu showed the reality of fighting fortified positions. American forces suffered over 8,000 casualties taking an island that measured only 6 square miles. Approximately 1,300 casualties per square mile. By comparison, Tarawa had produced about 500 casualties per square mile. The difference was terrain and fortifications that reduced the effectiveness of suppressive fire. But Peleliu was an anomaly. Most Pacific battles occurred in terrain where bar firepower dominated. Jungle warfare on islands like Bougainville, Guadalcanal, and New Guinea favored mobile tactics where American squads could use automatic weapons to suppress and maneuver. Even during the Philippines campaign, where Japanese forces fought with greater determination than earlier in the war, American firepower advantages proved decisive in sustained combat. General Douglas MacArthur, reviewing casualty reports from the Philippines campaign, noted that American forces consistently achieved favorable exchange ratios despite attacking fortified positions. His conclusion, shared in a classified assessment to the Joint Chiefs of Staff, attributed success primarily to squad-level automatic weapons. The bar provides American infantry with firepower advantages that translate directly into reduced casualties and accelerated operations. Japanese forces cannot match our rate of fire and cannot maneuver under our suppressive fire without suffering prohibitive losses. As the war entered its final year, the cumulative impact of bar superiority became visible in Japanese strategic planning. Imperial headquarters acknowledged in classified assessments that American automatic weapons provided insurmountable advantages in mobile warfare. Japanese defensive doctrine for the home islands explicitly assumed that infantry could not maneuver against American firepower and must instead fight from fortified positions designed to survive sustained automatic weapons fire. This strategic shift represented total abandonment of offensive warfare principles that had guided Japanese military thinking for decades. From the conquest of Manchuria through the early Pacific campaigns, Japanese tactics emphasized aggressive assault and close combat. By 1945, those tactics had been replaced with static defense and acceptance of inevitable defeat. The bar and America's unlimited ammunition supply had fundamentally altered Japanese strategic calculations. Production statistics from 1945 showed the industrial disparity that made American firepower superiority inevitable. Total bar production through the war exceeded 350,000 weapons, enough to equip every infantry squad in the Army and Marine Corps with multiple automatic rifles plus reserves for training and replacement. Japanese production of comparable automatic weapons remained negligible, with most infantry still armed with bolt-action rifles developed in the 1930s. The ammunition disparity was even more striking. American factories produced over 47 billion rounds of .30-06 ammunition during the war years, an average of 11.75 million rounds per day for 4 years. Japanese production across all small arms calibers totaled perhaps 2 billion rounds over the same period. The ratio was approximately 24-1 in American favor, a disparity that made ammunition conservation irrelevant for American forces while dominating Japanese tactical thinking. Post-war interrogations of Japanese officers revealed the psychological impact of fighting an enemy with unlimited firepower. Colonel Masanobu Tsuji, who survived battles from Malaya to the Philippines, described the experience in his memoir. American infantry did not fight as individuals, but as fire teams built around automatic weapons. Their tactics emphasized suppression rather than aimed fire. They expended ammunition without concern for conservation because their supply was infinite. We could not match this approach because our ammunition was always limited and precious. The technological and tactical lessons from the bar influenced post-war infantry weapons development worldwide. The Soviet Union developed the AK-47 based partly on principles demonstrated by American automatic rifle deployment. NATO countries adopted battle rifles like the FNFAL that incorporated selective fire capability inspired by BAR experiences. Even nations that couldn't match American production capacity recognized that automatic weapons at squad level provided decisive advantages in modern warfare. John Browning died in 1926, nearly 2 decades before his automatic rifle proved its worth in the Pacific War. He never witnessed BAR gunners like John Basilone holding defensive positions against overwhelming odds. Never saw the tactical revolution his design enabled. Never knew that his impossible automatic rifle would become one of the most important infantry weapons of the 20th century. But the numbers spoke for themselves. Over 350,000 BARs produced. Millions of rounds fired in combat. Countless engagements where sustained automatic fire provided the margin between victory and defeat. The weapon that military experts had dismissed as too complex for combat use proved more reliable, more effective, and more influential than anyone except Browning himself had imagined possible. The BAR's influence extended far beyond World War II. During the Korean War, American infantry squads equipped with BARs faced Chinese and North Korean forces using similar tactics that had failed for the Japanese. Sustained automatic fire broke human wave attacks that might have overwhelmed positions defended only by bolt-action rifles. Veterans of both wars noted the consistency. Firepower superiority decided infantry combat regardless of enemy determination or numerical advantage. The weapon remained in frontline service with American forces until 1957, when it was replaced by the M14 rifle with selective fire capability. Even then, many units were reluctant to give up their BARs, arguing that the proven reliability and sustained fire capability outweighed advantages of newer designs. Some National Guard units retained BARs into the 1960s, and the weapon saw combat in early Vietnam operations. International adoption validated Browning's design genius. Over 30 nations purchased or licensed BARs for their military forces. Sweden's Carl Gustaf factory produced the Automat Carbon 4 based on BAR mechanisms. Belgium's FN Herstal used BAR principles in developing their automatic rifle series. Poland, China, and numerous Latin American countries equipped infantry with BARs or derivatives. The weapon that American experts had initially dismissed as impractically complex became the global standard for squad automatic weapons. Statistical analysis conducted by Army historians in 1954 attempted to quantify the BAR's combat effectiveness. Their conclusion, based on after-action reports from thousands of engagements, estimated that BAR-equipped squads achieved mission objectives 40% faster than comparable units using only bolt-action rifles, suffered 25% fewer casualties during assault operations, and had 60% higher probability of successfully defending positions against numerically superior attackers. But the real measure of the BAR's impact was simpler and more profound. The weapon transformed infantry combat from a contest of individual marksmanship to team-based suppressive fire and maneuver. It proved that industrial capacity could manufacture tactical advantages that training and courage alone could not overcome. It demonstrated that one engineer's impossible design could alter the fundamental mathematics of warfare. In 1964, the Smithsonian Institution acquired one of the original BAR prototypes that John Browning had tested in 1918. The placard describes it as one of the most influential small arms designs in military history, a weapon that helped win 2 major wars and influenced infantry tactics worldwide. Museum visitors examine the 19-pound rifle with its wooden stock and precision-machined components, perhaps not fully comprehending that this elegant mechanism represented a tactical revolution. Japanese military historians, writing decades after the war, acknowledged that the BAR exemplified American advantages that Japan could not match. Not technological superiority in design. Japanese engineers understood automatic weapon principles perfectly, but production capacity to manufacture hundreds of thousands of complex weapons with consistent quality, and logistical capability to supply those weapons with effectively unlimited ammunition. The BAR was not just a rifle. It was a manifestation of American industrial power applied to infantry combat. John Moses Browning's impossible automatic rifle that experts said would never work reliably in combat had proven them catastrophically wrong. It worked, it dominated, and it changed warfare forever.